Hi, my name is Carin Papendorp, and I'm an MD PhD candidate at Brown University. For my thesis, I study autism, and autism is a condition that starts very early when the brain is still developing. It turns out that a biological process called epigenetics is very important for brain development. So first, I'm going to explain what epigenetics is, and then we'll talk about how changing epigenetics can lead to autism. One tiny cell in your body has about 6 feet of DNA, the molecules that contain your genetic code. And all that 6 feet of DNA needs to get squished into a tiny little cell nucleus. Every cell in your body has the exact same DNA, and that genetic code gets made into proteins that help cells work. But cells in your body differ in the proteins that they need. So for example, if you're a stomach cell, you're going to be using certain stomach genes a lot to make the enzymes that digest your food. And if you're a brain cell, you're going to need a very different set of genes to do your job as a brain cell, while those digestion genes can stay silent and squish together. Think of how in the summertime, you might pack away all your winter coats and sweaters and put them in the basement. You still have those clothes in your wardrobe, but you don't need them right now, so you can put them away. Meanwhile, when it's summertime, you'll have all your shorts and bathing suits in a place that's easy to access. Similarly, for efficiency, cells can pack away DNA that they don't need and take out DNA that they're actively using. This process of packing and unpacking DNA happens through epigenetics. And again, it helps cells be most efficient. This efficiency is especially important during times when cells need to make a lot of proteins really quickly. For example, when the brain is developing. Just like it might take you a while to get dressed on a snowy morning if you can't find your sweater and boots, it might take a brain cell longer to develop if it can't find the right genes. Surprisingly, it turns out that many autism-associated genes are related to epigenetics. In my research, I focus on one specific gene called ASH1L. Children with mutations in this gene have autism, but no one knows the exact reason why disruptions in ASH1L lead to autism. What we do know is that in people without autism, ASH1L helps pack and unpack the DNA in the nucleus. So for my thesis, I studied mice with mutations in ASH1L to try to figure out why loss of ASH1L causes autism. Without ASH1L, some genes are turned off when they should be turned on. For the brain cells, this is like wearing a heavy winter coat when it's 80 degrees outside. And although I haven't gotten there yet, my hope is that by changing epigenetics, I might be able to help the brain develop normally in mice without ASH1L.